Today, calculus is one of the most important branches of mathematics with applications in science, engineering, and economics. But who invented this wonderful tool? As with many questions of invention, the answer is a little complicated. Most mathematicians will tell you that two men deserve the credit for the development of modern calculus: Isaac Newton and Gottfried Leibniz. Of course, Newton and Leibniz were merely the next links in a long chain of discoveries that led to the creation of modern calculus. The ancient Greeks had first dipped their feet into the field, with the famous mathematician Archimedes being the first to find the tangent to a curve, and Antiphon of Athens developing the method of exhaustion, an early technique to compute the area of a region. Then the Indians added their own discoveries, with the astronomer Aryabhata expressing an astronomical problem in the form of a differential equation in the year 4099, and Parameshvara of Kerala developing an early version of the mean value theorem in the 1500s. Finally, during the European Enlightenment, men like Fermat, Pascal, and Isaac Barrow further pursued the emerging new field, developing the concept of the derivative. Barrow even offered the first proof of the fundamental theorem of calculus, linking the concepts of differentiation and integration. However, it was one of Barrow's young students, a certain Isaac Newton, who would make the next big splash in the creation of the art of calculus. Let's talk a bit about young Isaac for a moment. In his 84 years, Isaac Newton would discover gravity, write the three laws of motion, formulate a modern theory of the origins of colors in the visible spectrum, develop an empirical law of cooling, discover the binomial theorem, kickstart 200 years of intellectual freedom in the Enlightenment, move the British pound to the gold standard, and of course, invent calculus. Newton's rival, Gottfried Leibniz, was no intellectual slouch either. Leibniz developed the binary system that is the basis of all modern electronics, contrived his own theory of everything, the monadology, invented modern formal logic, anticipated the discoveries of Einstein with his metaphysical theory of dynamism, theorized about an early computer to solve algebraic expressions, explored the field now known as topology, created a wonderful brand of German biscuits, and of course, invented calculus. Strangely enough, both men invented calculus, but to their graves, the world believed that only one man was telling the truth. The question was, who? In 1666, Newton was one of the many students at Cambridge University who were sent home on account of the plague. In his spare time, Newton developed what we now know as calculus to solve physics problems. However, he called calculus the method of fluxions, fluxion being Newton's term for a derivative of a continuous function. Newton mainly used geometric proofs for his new theory, and relied on limits in concrete reality rather than concepts in theory. However, as was typical with Newton, he withheld his extraordinary findings for many years, refusing to publish them for the rest of the world. Meanwhile, young Gottfried Wilhelm Leibniz, a German philosopher and mathematician, began working on his calculus in 1674 while staying in Paris. On November 11th, 1675, he made a breakthrough, finding the area under the graph of the function y equals f of x. He invented a whole new system of notation for his discovery, using an elongated letter S for the Latin word summa for integration, and the D for the Latin word differentia for differentials. Leibniz published his first account of differential calculus in 1684, and then published an explanation of integral calculus in 1686. A year later, in 1687, Newton finally got around to publishing his findings, producing the Philosophiae Naturalis Principia Mathematica, which has since been hailed as the greatest science book of all time. In the book, Newton described his famous laws of motion, his law of universal gravitation, and the derivation of Kepler's laws of planetary motion. Throughout the book, Newton used his new tool, calculus, to back up his physical theories. However, since Leibniz had published first, it was Leibniz, not Newton, who got sole credit for this amazing new field of mathematics. In retrospect, both men's calculus work had problems. Newton's calculus lacked a standard notation and heavily relied on geometric proofs of infinitesimals. Leibniz and Newton both based their work on this concept. Infinitesimals were quantities that were not zero, yet smaller in absolute value than any real number. They were necessary because the concept of the limit had not yet been invented, so without infinitesimals there was no way to properly study a continuous function. Unfortunately, infinitesimals were on shaky philosophical and mathematical ground, and many refused to accept a calculus based on these infirm ideas. But back to Newton. Determined to prove that he was the sole inventor of calculus, Newton embarked on a 17th century smear campaign to prove that Leibniz had plagiarized. Fortunately for Newton, there was plenty of circumstantial evidence in his favor. Many of Newton's colleagues had connections to Leibniz, and some of Newton's unpublished manuscripts may have found their way into Leibniz's hands. Newton and Leibniz had also corresponded by letter quite frequently, sharing ideas about mathematics. In fact, Newton's first descriptions of calculus, including the binomial theorem, fluxions, and tangents, first appeared in letters he wrote to Leibniz. Newton also had powerful allies working in his favor. Following his publication of the Principia Mathematica, Newton became something of a scientific celebrity, winning the support of the prestigious British Royal Society, which would become his main attack dog on Leibniz. Unfortunately, in contrast to Newton's popularity, Leibniz had few allies. When his friend, mathematician Johann Bernoulli, tried to defend Leibniz's credibility in a letter to Newton, Newton pressured Bernoulli into retracting his statements. Nearing the end of his life, Leibniz gradually lost control of the argument, and Newton became known as the father of calculus. In 1715, the Royal Society officially proclaimed Sir Isaac Newton as the sole discoverer of calculus. Leibniz died only a year later, having lost much of his credibility. Even after his death, Newton and the Royal Society worked to discredit Leibniz. They claimed that Leibniz's different notation was just a mask for his treachery, despite the fact that it was actually more efficient than Newton's dot notation. However, in spite of the rulings of the Royal Society, mathematics in the rest of Europe continued from where Leibniz had left off. Newton's fluxional calculus was discarded in favor of Leibniz's methods, which were more efficient and applicable. However, as a matter of national pride, England refused to use Leibniz's methods, sticking to Newton's outdated method of fluxions. As a result, while the mathematics of continental Europe advanced, British mathematics languished. It was only until 1820 that Britain finally recognized the work of foreign mathematicians, and the march of mathematical progress could continue. Only the passage of time has revealed the true answer to the calculus controversy. After careful analysis of both scientists' papers, most historians have come to the conclusion that both Newton and Leibniz invented calculus independently. Though, as Newton claimed, Leibniz had indeed seen some early manuscripts of the Principia, by this time he had already come to his own conclusions. Both men had collaborated by letters in developing concepts like the power series and had known of each other's progress. Further analysis of both men's methods has provided more evidence. Newton, who had used calculus as a tool for physics, had approached calculus from the derivative as applied to motion and velocity. On the other hand, Leibniz had taken a geometrical approach, basing his discoveries on the work of previous thinkers like Descartes and Pascal. This is perhaps the most conclusive evidence that both Newton and Leibniz were independent inventors of calculus. While modern controversies are so often about celebrity divorces or boys and balloons, the fact that the best remembered controversy of the 17th century was about the invention of an advanced mathematical field speaks volumes. In spite of all the hubbub about who invented what and when, both Isaac Newton and Gottfried Leibniz are perhaps best remembered as pioneers of mathematics, adventurers who pushed the limits of human comprehension to new frontiers. For that, both men deserve the utmost credit.